Welcome to watch the video about National Sun Yat-sen University Physics Demonstratory Experiences. Our group is talk about angular momentum. What is angular momentum? Angular momentum it sounds like a very professional pronoun, but actually it is existed in our surrounding everywhere, like the car on the ground and the helicopter in the sky. Why does our life filled with angular momentum? Angular momentum, the most important work of angular momentum is that it can provide a steady station of motion to an object, like this football. If you pass this football without a rotation, then there is no angular momentum work on it. It doesn't rotate and its passing track will be very unstable. But if you pass it with a revolve, there is an angular momentum to protect it. Then it will securely in passing to a teammate. When it comes to angular momentum, it cannot avoid to speak about factor. Factor is the thing that it contains the directional and quantity. And the role of judge the angular momentum's direction is that we must use our right hand. And it we call right hand rule, like this small well. If it is rotated counterclockwise, our four fingers turn it like this, and our four fingers turn counterclockwise too. Then our thumb is upward. It means angular momentum's direction is upward. Our group will introduce the special case about angular momentum. It we call angular momentum conversation, and the common phenomenon is called precession. Precession is the thing that you will see in your normal life.
Now, I will introduce a special statement. It is angular momentum conservation. What is angular momentum conservation? It's just like energy conservation. Term means the entire distance statement before and after are the same. Time is not influence of external torque. We now demonstrate the direction of angular momentum conservation. Now we will show you an experiment. Look, a model stands on a turntable and he holds a wheel, and I give him an angular momentum and he changes the direction of angular momentum. Oh, magic! While the model rotates on turntable, in order to maintain angular momentum conservation, we can first, as we can see, the direction of angular momentum is upward, and the model changes the direction, is downward. So the model will get upward angular momentum. So the model will rotate. And in our life, there are many examples in our lives.
This experiment, we use dumbbell to illustrate the angular momentum. First, I will show you two rules. The first one is angular momentum equals to the moment of inertia multiplied Now I'm going to show you this experiment. First, we rotate this model. And you can find when he put his arms close to his body, he will rotate more quickly. And why? It's because when he put his arms close to his body, the radius reduced and the moment of inertia decreased. When the moment of inertia decreased, in order to make the angular momentum conserve, so the angular velocity omega have to increase to make the angular momentum conserve.
Now, I would like to show you another common phenomenon in the rotating wheel. To begin, I put a rotating wheel on my hand. As you see, the wheel seems to have another axis while rotating on its own axis. This is a repetition of precession, and the top is another example in our life. So, what causes the action? When the wheel is tilted, the gravity will exert a torque on it, and the torque's direction is vertical to the wheel's previous angular momentum at any time. This torque results in a change in the direction of the wheel's angular momentum. This torque results in a change in the direction of the angular momentum of the wheel. So it behaves as if it has another axis. By the way, our Earth has a similar phenomenon too. This torque results in a change in the direction of the angular momentum of the wheel. So it behaves as if it has another axis. Our Earth has the same behavior too, but it's too obscure for us to observe in a short period of time.